Okay, so you're doing 7.4 tonight, and just in case you had a little trouble, let this be a guide. First and foremost, in bold and capital, so you may not have noticed it, it says draw sketches and set up all energies if you're doing that law of conservation of energy. You can stay put. And how you do that with the sketches, you need to, just like W7.4, keep track of the energies at different locations. So we have a ball being dropped from a height. Here's the ball at height. Here's the ground. The height we know is 5 meters. The first question is about the ball's kinetic energy when it is 2.5 meters above the ground. So the ball will then be here at 2.5 meters. Yes, you need this picture. You need this picture because just like W7.4, you will identify the types of energy at each location. At the beginning, it has height, so it has PEG. It does not have speed, it does not have a spring, and it does not have any friction, so none of the others. At the mid-height, many of you will recognize that it has KE. It does, but that's not all it has. It also still has height. So in fact, you have to keep track of that height via its PEG. Now that you know PEG is turning into PEG and KE together, you can properly solve this problem. So the way you can do that is using the law of conservation of energy, because we know that the total energy before, which is at the beginning of the problem, will match the total energy after, and that after is at our 2.5 meter height. And so really what that breaks down to is exactly what we drew in the diagram there. Before, at the beginning, we have only PEG. After, at the 2.5 meter mark, we have both PEG and KE. So, the key to this is recognizing the before and the after. Before, it is at 5 meters. So when you run your MGH over here, the H is going to be 5 meters. When you run your PEG with your MGH over here, the H is going to be 2.5 meters. Then the question asks for kinetic energy, so there's really no need to break this into 1/2 mv squared. Since they're asking for KE, you leave it as KE, run the numbers, and solve for KE. Use a similar approach when dealing with the bowling ball pendulum down here. First couple questions you can think about what we did in class, and then question 6, what is the maximum speed reached and where does this occur? Well, probably you know where it occurs, but you need to keep track of the energies again, PEG, and here it has KE, of course, but it still has height, so it also has PEG. And you go through a similar process to what you did with question 1.